Hello, Mr. Beeline here with your math lesson for today. We're talking about functions as equations or equations as functions. Here we go. So, functions, right, what we've been learning in the past couple lessons are relations that have for every one input has one output, right? So we can also represent these functions as equations. We don't need those tables necessarily. We don't need the mapping pieces, right? We can just represent it through an equation. These equations can then generate these tables of ordered pairs, right? They can make these ordered pairs, and the way that they do that is by taking an input, applying the function to it, and giving you the output, right? So you apply something to your input, making the output. This could make a graph, right? You can make a graph of an equation, and this graph will be the set of all of those ordered pairs. This will likely be continuous, right? It'll be the set of all of them, and you'll get a line or a curve. So to kind of have a better picture of this, we have our x, right? And our x is considered the independent variable. We get to pick what that number is going to be, right? If we're talking about boiling water and trying to find the temperature of water, we get to pick what time we check the water at, right? We don't get to pick the temperature. The temperature is solely based off of how long it's been left in the kettle, right? So the independent variable is the x. That's what we're putting in. The function is like the machine that will change it and do something to it. So we put in our number or our value. The function will mess around with it, change something inside, and spit out this y value. And this is our dependent variable. Another good illustration of this is actually Dr. Seuss's The Sneetches. So if you haven't ever read that story, it's about these creatures or these people who go into this machine to get stars put on their stomachs, right? So they don't have a star on their stomach. They walk into the machine does something to it, puts a star on, and they come out with stars on their stomach, right? So that would be your x, function y. Okay, so again, this is a lot of words. What does this actually look like? Well, let's go through it. Okay, so we're going to just start off with a pretty straightforward equation. Y equals x plus 4. Y equals x plus 4. Again, we get to pick whatever x's we want to put in, and that will tell us what the y is supposed to be. Okay, so let's start by making a table, right? We can make these tables ourselves based off this equation. So x and y, independent variable tends to go on the left, dependent variable goes on the right. So we'll start with 0. That's a good one to start with. What happens when we put 0 in here? We get 0 plus 4, y equals 4. And then what about 1? 1, if x equals 1, then we have 1 plus 4 is 5. And what about 5? 5 plus 4 is 9, y equals 9, right? You could try a whole bunch of numbers, doesn't really matter. You get all these numbers plus all the ones in between. These are just some of the possibilities, right? This is infinitely long. I don't have enough time to write down an infinite amount of numbers. So I'm just gonna go with 4 numbers. Let's go with one more. Let's say 7. 7 plus 4 makes 11. Okay, so now we can graph this, right? So put our graph down, and the very first one we're going to want to put is that 0, right? So let me just mark off some points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, something like this. So 0, 4 goes right here. 1, 5 would go right here. 5, 9 would go right here, and 7, 11 would go right here. Again, those are specific points. We're going to want to put a line through this, and this would go on forever in both directions, right? I could put it -50 here if I wanted to. Okay, so again, there are a whole bunch of other examples there. Give those a try, and then I will show you how to do it through a domain set in another video. Okay, try those and then check out the next video.